Good day, everyone. Welcome to class once again today. So, in the last class, we started looking at logarithm and we looked at the laws of logarithm. We looked at the relationship between the indices and logarithm, and we saw that if we have log m 10 is 10 is the same as log m is 10 plus log n is 10. We also saw that log m over n, for instance, is the same as log m is 10 minus log n is 10. We also saw that log a raised to power x is 10 is equal to x log a is 10. Another thing we saw under the law of logarithm is that the log of any number to its base is 1, and the log of 1 to any base at all is 0. So this is just the brief summary of what we looked at under the laws of logarithm, and we also looked at how to solve logarithmic equations, and we looked at substitution of a logarithm. So, and I gave you an assignment. Check the comment section for the solution of the assignment. All right, today we will be looking at another aspect of logarithm, and we'll also be looking at the use, of course, we're looking at the use of tables. I'm sure you are aware of log table, a logarithmic table. So sometimes you could be given a problem to solve and you're asked to use a logarithm table. So we'll be looking at how to use a logarithm table and the operations involving them. But before we do that, we'll just do a very brief revision on standard form of numbers. Now, if we're looking at standard form, I'm sure you're very familiar with that term, standard form of numbers. What are we talking about? We know that the standard form of a number has the form a times 10 raised to the power of n. Okay, now where a is a number that can be any of the integers 1, 2, 3, 4, 5, 6, 7, and n can be a positive or negative number. And so when you see a number such as 7, 7 in standard form, of course, we know according to even the law of logarithm is 7.0 times 10 raised to the power of 0. Now the number 60, the standard form, is 6, sorry, 6.0 times 10 raised to the power of 1. Now someone may be asking, how do I know where to raise to the power of 10? Now assume, of course, you know that at the end of every whole number there is a decimal point. Once I feel this, see, I'm moving once. So because I moved once, this is 10 raised to the power 1. That's the layman approach to it. On the other hand, you know that 60 is 6 times 10. Now, if you have something like 8156, now we know that this is 8.156. 1, 2, 3. 8.156 times 10 raised to the power of 3. What if I have 0.094? I'm going to have this time around 9.4 times 10 raised to the power of 1, 2 times 10 raised to the power of minus 2. Okay, so this is just a brief revision. So I will now introduce um, to you that the logarithm of a number consists of two parts. So when you see the logarithm of a number, we know it consists of two parts. The first part is what we call the characteristic, and the second part is what we call the mantissa. Now the characteristic is the whole number part, is the part that is a whole number, and mantissa, of course, is a decimal. So if the logarithm of a number is gotten as 0 point, the logarithm of a number is gotten as 0.7782. Of course, you know that the characteristic is this 0 and the mantissa is 0.7782. Okay, so if that is clear enough, now I will show you the relationship between this and the standard form of numbers. Now, I'll give you a table that you must study carefully. If I have in my table numbers and I have standard form of numbers, and then I have the logarithm of that number. Of course, because I have told you that logarithm is divided into two parts, we have the characteristic and then we have the mantissa, and of course I now have my answers. Now if I have the number, if I have the number, if I have the number 5, I know that the standard form of 5 is 5 times 10 raised to the power of 0. So now from this standard form I can guess what the characteristic of the logarithm of 5 is going to be. I can guess that the characteristic, of course, always the characteristic is always this 0, this power. So my characteristic is 0, and of course using my log table I can now find the mantissa. So we have 6990. So finally my answer will be 0.6990. Now let me just give you another number. If I have 8156, if I use a log table, my answer would be, okay, my standard form would be, without using a log table, 8.156 times 10 raised to the power of 3. Now, you can you can know your characteristic from this value of the standard form. Your characteristic should be this power of 10, which is 3. So if I want to find the answer to this log, it must be 3 point something. After using your logarithm table, which you will learn how to use, you will discover that you have 9115. So that point 9115 is your mantissa. Okay, finally on that, given the number 0.0082, of course the standard form is 8.2 times 10 raised to the power of minus 3. In this case, your characteristic would be minus 3, or of course in logarithm what we use is bar 3. So when you're writing your answer, it will be bar 3 point whatever your log table gives you, 9138. Alright, so get your log table handy. If you don't have a logarithm table, your mathematics textbook has a logarithm table at the end. Alright, so let's solve some questions and see how we can use the logarithm table to express numbers. Okay, using logarithm table, evaluate 69.24 times 8.31 times 8.31. Now, one of the first things you do is to draw a table, write number, write log, and then of course write out the number 69.24 and then write 8.31. Now, for you to find the logarithm of this number, before you start using your log table, you must find the characteristics first. Now, 69.24 in standard form would give me 6.924 times 10 raised to the power of 1. So, which means my characteristic will be the power of 10, which is 1. So, I have 1 point. Or another easier way to do it is just to know how many times you have to move this point to come to the front of the first number. So I have 1 point. I've not started using my logarithm table yet. Now for this, you will observe that this number is already in the form of a standard form. So it doesn't need, this point does not need to move. So your characteristic will be 0. You have 0 point. Okay. Now, that being said, you now start using your logarithm table. If you use your logarithm table, you will discover that your logarithm table has rows and columns. Your logarithm table has rows and columns. And in the rows and columns, you will see several numbers. I'm sure you're seeing it now. Please take a look at your logarithm table. You see several numbers. Now, you will also see a place where they wrote differences. Okay, if you have seen that, now look through the columns. There's a place you have from numbers 10 down. Now look for 69. So you always take the first two numbers. Look for 69. When you get to 69, hold 69. Hold 69. Now check for 69. Trace it to under 2. You see some numbers at the top of the table. You have 0 to 9. Now trace 69 to where you have 2. You will discover that what you have there is 8, 4. Okay, let me just give you a picture of what the table looks like. You're going to have, there's a place they wrote X, then you have 10, 11, 12, 13. And let's assume you have 69 somewhere. And then at the top of your table, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you now see where they wrote difference. Under the difference, you also have 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you have seen that, now, trace 69. I'm sure you're watching the screen. Trace 69 under 2. 69 under 2. Check the value you have there. If you're doing it right, you discover that your value will be 8401. 8401. Keep it somewhere. Now, that's not the end. Remember, the number you have is 6924. You have 69.24. So you've done 69.2. Now look for difference 4. So still trace this 69 to difference 4. What number do you have there? So your 69 to difference 4 will give you 2. Alright, now that 2, add it to the number you had got, which is the 8401. You will discover that what you have is 8403. So you come to this your table and write 8403. I'm sure that was clear enough. Okay, now that's for the first number. Let's try this for the second number. While you're trying it on your own, I will also try to get it. Now for my second number, I have 831 as the numbers I'm considering. 831 as the numbers I'm considering. Okay, now what you do, you always take the first two numbers. So you trace down until you find 83. From that column of X, find 83. Now because the next number is 1, so find 83 under 1. So this number here is what you will use. 83 under 1. These are the terms we use for that. So you discover that if you're doing the correct thing, your 83 under 1 should be 9196. 9196. So since there is no other number, you just make do with 9196. Okay, that being said, you will come to your table now and add up. Now because you are multiplying, remember the laws of logarithm. When it is multiplication, we add the log. So you add up, you add your logarithm. If we add, of course, you have 9, 5, 7, 2. Okay, then this is not your final answer. When you've gotten this, you must find the anti-log. So go back to your table. There's a place they wrote anti-log. Another table that looks like this, but what you have is anti-log. Anti-logarithm. Now when you're looking for your anti-logarithm, now you must treat these two. Sorry. Okay. You must treat these two here. I've highlighted it as if it doesn't exist. Now on your anti-log table, you would observe that unlike the logarithm table, what you have instead of 10 on this column, watch my table, on this column, you will observe that what you have is 0.00, 0.01, 0.02, 0.03. Now on that table, look for 0.75. Look for 0.75. So let's assume that 0.75 is somewhere here. Okay, mind you, we are on the anti-log table. They wrote anti-logarithm there. So 0.75, the next number is 9. 0.75 under 9. 0.75 under 9. 0.75 under 9. 0.75 under 9. So I will trace this to 9. So it will be this value here. 0.75 under 9. What did you get? If you're doing the correct thing, 0.75 under 9 should give us 5741. 5741. Okay, 0.75 under 9. Now there's another number there, another 9, difference 9. So you still trace this to difference 9. So what number do you have there? Still on the line of 0.75. So difference 9 you will observe is 12. So add that 12 to your 5741. You discover that you have 5753. If you have done that, come to your table, write anti-log equal to 5753. But remember that you won't stop here. You remember, look at the screen, you will see that I highlighted 2 there. Okay, now I have highlighted 2. There's something you must do with that 2. Because I highlighted 2, add an imaginary 1 to 2, you will have 3. So what it means is that you are going to move 3 steps from the decimal place before the first digit. So you're going to move this way, 1, 2, 3. So your final answer will be 575.3, and that will give you the answer. Okay, we'll try one more and then we'll see how far we'll go from there. All right, I will leave the table for practice. Okay, using logarithm table, evaluate 7031 divided by 4911. Okay, now remember that the first thing we do is to draw our table number long. Then write out the number 7031 and the other number 4911. Okay, if you have done that, then remember that the next thing to do is to find your characteristic. So push from here, you have 1, 2, 3. So your characteristic is going to be 3. For this one, sorry, we have 4.911. Sorry, not 4911, 4.911. We're working with 4.911. Okay, now for this one, you discover that the decimal point is already where it should be. So the characteristic will be 0. Okay, the characteristic will be 0. All right, now we go over to our logarithm table. Logarithm first before anti-log. Okay, now for me to find 7031, remember your column. Remember the column that is written logarithm on. Now when you go to that column, look for 70, the column that has 10, 11, 12, 13 and so on. Let's assume 70 is somewhere here. Okay, if you found 70, the next number there, if you use 70, the next number is 3. So you look for 3. So you're going to find 70 under 3. So tracing this to 3, the value here is what I'm going to use. And if you're doing the right thing, you discover that your value is 8470. Right now, 8470. Now you're not done. There is also a remaining number 1. So you still trace it to difference 1. Difference 1, this is difference 1. So the value here, that would be still under 70, of course. 70 under difference 1 will give you 1. So you add 1 to this. You have 8471. So you come here and put 8471. Alright. If we've done that, I'm sure you're making progress. If you've done that, we'll come to the second number and continue the same process. Continuing the same process will give us that we'll look for 49. So you look for 49 under 1, difference 1. So let's assume 49 is here. 49 under 1 will be the value here. Difference 1 will be the value here. So 49, remember you're doing all of this with your logarithm table. So 49 under 1 is 6911. I write it out somewhere. 6911. Difference 1 would give me 1. So that would be 6912. 6912. Okay, I'm sure that was not difficult for us to do. Now, we concentrate on our table right now. So we have, because we are dividing, remember that we are dividing. Remember that we are dividing. Remember that we are dividing. Now, whenever we are dividing in logarithm, we subtract. So if you subtract, you're going to have 11 minus 2, 9, 6 minus 1, 5, 14 minus 9, 5, 7 minus 6, 1. So you have 3.1559. At this point, you would find your anti-log. Remember that before finding your anti-log, you will act as if this 3 does not exist. Okay? Now, so what we are looking for, remember that for your anti-log now, for your anti-log, you're going to have something on your table. Now, you go to your logarithm table for where we have anti-logarithm. So we are going to have, remember that what you have is 0.01, 0.02, 0.03. So you're starting with 0.15. So let's assume 0.15 is somewhere here. Let's assume 0.15 is somewhere here. So you check for 0.15 under 5. So 0.15 under 5. Looking at your table, you will observe that 0.15 under 5 will give you 1429. So you write that 1429. And you're not done. Remember, there is a number remaining here, 9. So 0.15 under 5, which is something like this. Difference 9 will be something, a value here. Difference 9. So difference 9 would give us 0.15 under 5, difference 9. I'm sure you're looking through your table now. Difference 9 is 3. 3. 3. So what do I do with it? I add that 3 to this 1429. So I'll have 12, 3, 1432. So this is my value for the logarithm. Now, having done all that, the only thing remaining is for you to deal with this 3. Remember that there was a 3 at play here. Now this is the 3. What do I do with this 3? I add an imaginary 1 to this 3, which will give me 4. And then from this point, I move 4 times. 1, 2, 3, 4. So my final answer will be 1432. And that will give us what we are looking for. So your final answer is 1432. I'm sure that was clear enough. So as you can see, it's not really a big deal. All you need to do is just to practice consistently and you get used to it. Okay, one more different example that has to do with powers, and then I'll leave you with an assignment. Okay, using tables, evaluate. Okay, before we go to the powers, let's deal with numbers less than 1. All right, using table, evaluate 0.5624 times 0.0378. Now this is slightly different because we are dealing with numbers less than 1 now. And for numbers less than 1, the major difference is in your characteristic. Your characteristic is always in the negative. Okay, so we start. First things first, your table for your number, your logarithm. The first number is 0.5624. Second number is 0.0378. All right. So the first thing is to find your characteristic. Now you see that this is for numbers less than 1. How many times do I have to move this point? Remember, we're doing the simple way. Of course, if you use the standard form method, the power of 10 will be 1. So your characteristic here will be 1. Put your point. For here you have 1, 2. Your characteristic will be 2. Put your point. Then of course you go to your logarithm table. And in the logarithm table, remember how it is structured. Here we have 10, 11, 12, 13. And remember, you start with 56. So let's assume 56 is here. We're going to find 56 under 2 difference 4. Okay, 56 under 2 difference 4. 56 under 2 difference 4. All right, bring up your logarithm table. 56 under 2. I'm sure you're looking at your logarithm table by now. All right, 56 under 2 will give you 7497. Was that what you got? 7497. Write it out somewhere so that you don't forget. And then once you finish tracing 56 under 2, remember which is here, trace it to difference 4. Difference 4 will be the value around here. So 56 under 2 difference 4 will give you 3. So you add that 3 to this 7497, and of course you have 7500. 7500. So you put your value 7500. Okay, now we are done with that particular number. We go over to the next one. For the next one, you have 37 under 8. That's what you'll be looking for. 37 under 8. 37 under 8. Let's assume 37 is here. We'll trace 37 to 8, which is around here. Now we don't need any difference because there is no other number from what we are given. So 37 under 8 using your logarithm table will give you 5775. 5775. Okay, because there are no differences, we'll just use 5775. Now remember that we are multiplying. We are multiplying, and because we are multiplying, we add. And once we add, the next thing would be to look for the antilog. So we have 5, 7, 2, 3. Oh, did you observe the mistake? the mistake that here we're supposed to have bar 1 because we're dealing with numbers less than 1. And we're supposed to have bar 2 here. And bar 1, of course, is same as minus 1. And bar 2 is minus 2. But we use bars when it comes to logarithm. Now, so what do we do? We've gotten to this point. 7 plus 5, 12. 7 plus 5, 12 plus 1, 13. Now you have minus 1 plus minus 2 plus 1, which is minus 1 minus 2 plus 1, which is minus 4 plus 1. Of course, that will give you minus 3. So what we have here is bar 3. Okay. Now that you have bar 3, you're going to do the antilog. So I find my antilog. Antilog. How do I find the antilog? The same way we've always been finding our antilog. All right. There will just be a slight difference. Now, picking up your antilog table, remember that for the antilog, we no longer have 10. We have it starting from 0.01, 0.02, 0.03, and then down to, we're looking for 0.32. Let's assume 0.32 is here. We're going to find 0.32 under 7 difference 5. So 0.32 under 7 is somewhere around here. So this value here, difference 5 is somewhere around here. This value here. So 0.32 under 7 for anti-logarithm. 0.32 under 7, of course, would give you 2123. Was that what you got? 2123. And remember that there is the part of difference 5. 0.32 under 7, 2123. Difference 5 would give you 2. Difference 5 is 2. So we add up these two here. We have 2125. So writing it out, we have 2125. Now, remember that all the while we were doing the antilog, we solved as if this 3 was non-existent. All right. Now, but we are going to use it now. That your 3, add an imaginary 1 to bar 3, you would have bar 2. So now, because of the bar, because of the minus sign, you won't move to the right hand side anymore. You're going to move to the left hand side 2 times. You have 1, 2. So this is where your point would be. Under this you have 0, under this you have 0. The final answer is 0.00212. That, of course, is your final answer. All right. One more example. Okay. Or I will just really give you an assignment from here, and then in the next class we will continue from where we stop because of time. All right. Take the assignment. Using logarithm table, evaluate, evaluate 1, 24.56 times 2.48, and then 2 evaluate 0.0035, sorry, divided by 0.6270. Okay, please do well to put your assignments in the comment section, the solutions to your assignment, and we will of course respond to them. And if you have any question, please kindly comment in the comment section. It was an awesome time once again with you. Thank you for listening. Thank you. Bye.